Hello, parents and any teachers or students who may be watching. Welcome to Creating Math Ahas. I'm Dr. Sandy Atkins, Sandy, and in this video, we'll focus on subtraction in grade 2. Now you can see some manipulative materials that I have here. I have some unifix blocks, and unifix because they connect in exactly one way. That's why they're called that. The nice thing about this will break apart. We use them in grade 1, and we may use them to help your child transition at the beginning of grade 2 to base 10 materials. Now you can see in the base 10, we've got a hundreds block, tens rods, ones. These cannot break apart, but they're helpful models. And as they move up through the grades, there's also a 1,000 block that they can work with. And then I have base 10 materials that have been made out of paper, cardstock paper, that is just really centimeter grid paper. And you'll see why this manipulative is sometimes more useful than this one as we get into looking at strategies and looking at meaning of subtraction. Now, in the Intro to Subtraction video, I talked about the meaning of subtraction, primarily removal or takeaway and comparison. And we also looked at strategies like round and adjust, decomposing a place, and then a counting up strategy. I want to look at those strategies with you for grade 2, but keep in mind these strategies are strategies that once learned in grade 2 will be able to be used with fractions, mixed number subtraction, and decimal subtraction as they move up into grades 4, 5, 6. So let's look at some of these strategies. Let me try to remove these without spilling them all over. Yeah. And see. Now, I want to start with a problem like 62, and I'm going to do minus 29. For some reason, this problem, a go-to problem to demonstrate with. Now, for 62 minus 29, I could use these base 10 materials. Whoops. And for many of us, we look at this and think, well, I can't remove 29 straight away because I don't have enough ones. And I know I've taught, and many of us learn trading this in. You trade this in for 10 ones, and then you can do it. Now think about when you go to the store and you buy something that costs 29 cents. Have you ever gone to the cashier and said, I'm sorry, I don't have enough pennies for you. Could you trade me a dime for 10 pennies and then I'll be able to pay you? I know I never have. I've given them 30 cents and they give me back my penny. Now keep that in mind. That's a real world way of handling removing 29 from something, right? If I have 62 here, I don't have to trade and get exactly 9 ones to remove 29. I can remove 3 tens and then give 1 back. I round and I adjust. So I remove 3 tens, give 1 back. That's very efficient. That turns this problem that we learned as a regrouping problem, or when I was in school, we talked about borrowing things, right? So it's a regrouping type problem, but we're using a very efficient strategy of round and adjust. Okay. Now, again, this will be able to be used when they get to mixed number and decimal subtraction. Okay. So I remove, I adjust. Now, if I were to draw the picture for round and adjust, so if I look at round and adjust strategy, I'm going to use just a line for 10 and dots for ones. So for 62, my picture would look something like this. I could draw all these squares, but that's not very efficient. So I'm just going to use this as my model. I'm going to use the round and adjust. So with round and adjust, I cross out 30 I remove 3 tens. Now, it doesn't matter which of the tens I cross out here. I'm just removing 3 tens and giving 1 back. Okay. Now, think about a problem like see, I can use the same strategy here, right? If I draw my picture, I'm going to use squares for my hundreds. Here's my tens and my 2 ones. If I want to remove 199, I don't have to trade this in, right? I can remove the 200 and give 1 back. A mental strategy. So the math hasn't changed, but we're using manipulative materials to help children develop these mental computation strategies, okay? And use those because they're extremely efficient. Now, let's go back to 62 minus 29. The other strategy we talked about is a decompose, and I'm going to say decompose a place. Okay. We call it decompose a 10 in grade 1 because we're usually working with combinations less than 20 and then starting to get into some teen numbers. Here, because we're going to be moving into 3-digit numbers, I can decompose a place, break it up, okay, instead of exchanging or thinking of an equivalent way. Now I'm going to start with my same drawing. And when I give this to children, I ask them to remove 29. They do this one. And then some children will remove 20. Again, it doesn't matter which 20 I remove. And then they cut this into 9 and 1 and remove the 9. Now, if I'm trying to use this material for cutting something, that's hard for me to do, right? I can't break this. I don't want them cutting it. Sometimes that's why we use this manipulative material, because I can break this into 9 and 1 easily. So that is the material we tend to use in grade 1, is we get them used to this. So when they transition to grade 2, this is not a jump. This is not required to be broken. Now, I also showed you a paper version. And in this paper version, you see, I could, just using a dry erase marker, I could have the children cutting it. And I could have them showing 9 and 1 here. But the nice thing with the paper version that's different from what we do with this is when I turn this over, I see all the lines still. When I turn this number over, see, I don't see lines. I can just see the outline as 9 and 1. And you may have some drawings early on where they're drawing this for a 10 and this for their 100 and this for their 1. And that might be starting drawings. And then I tend to move them here because when your children get in a hurry, quite often these start to look very similar. It's hard to distinguish the unit. So to help with that, we'll do a little different drawing. So I may use this to help them start to see how I could cut this into 9 and 1. And then I can decompose that 10 here. That's a transition I'm going to make. Now, that said, think about if I'm doing 199, or I want to break up some of these other values. So think about here. I could, if I just wanted to cut this into 99 and 1, I could just outline that and see I could decompose 100 into 99 and 1. Or I could break this 100. Let's just get practice, I could do it as 70 and 30. But I think you agree, I don't want them drawing a square with 100 little squares in it. That's not efficient. Again, I could turn this over, and using that same idea, see, this helps me see a way to break that 100 up. So we're purposeful in how we choose the manipulative materials that we're using. We want to be purposeful in setting them up for these transitions to more efficient drawings. And some folks say, well, they know that regrouping algorithm I learned. Why don't they know that? Why isn't that okay? They can just use that one all the time. That is a great arithmetic procedure that will get you the answer. The struggle we have sometimes is for a problem like this, that's not the most efficient strategy to use. And remember in that 5 strands video, I'll try to leave the link below, but in the 5 strands, we know that procedural fluency requires flexibility, being able to get answers in more than one way, being playful with number, and having efficient ways to get those answers. So we're wanting to look at these strategies that are still efficient. Math is not new, very efficient, but we're using models in precise ways. Now let's look again at 232 minus 199. And we have a child who wants to use this decompose strategy. And they're really focused on place value. They understand that 199 is made up of 100 plus 90 plus 9, and they've got to figure out how to be able to remove all of that. This is called expanded form of a number. We're preserving place value. We don't see these as a 1, a 9, and a 9. We understand the size of the unit. Now, if I want to remove 100, easy enough, there goes the 100. If I want to remove 90, well, I can cut this into 90 and 10, right? So I remove the 90. I have that 10 sitting there. I need to remove 9. I can cut this into 9 and 1 and remove the 9. See, in grade 2, we really try to get them comfortable with using place value approaches. And these other approaches, it's foundational to work with fractions and decimals. It gives them that playfulness and it builds understanding of place value. Where when I learn that one algorithm procedure, we treat every place as the ones place. We didn't get a chance to keep reinforcing place value. So when I remove these, you can see, what am I left with? I've got 10, 20, 30, 33. I still will get 33 using this strategy. Now, one more way that your children will use 62 minus 29, I'm going to start with this same drawing. Quite often what they'll do is they remove the 2 1s and 2 10s and know they still have 7 left. Still 33, okay? So all efficient. This is decomposing a place, right? We decomposed a 1 here. We decomposed the 100. We decomposed a 10 to get at those answers. But those strategies, round and adjust, decomposing a place, using our understanding of place value to solve. Okay. Now, one other model I'd like us to look at that we use for counting up is a total part-part chart. If I turn it this way, we tend to call it a part-part total chart. I have the 2 parts, I want to find its total. If I turn it this way, total part-part, I know it's total, I'm trying to find its parts. If we stick with our 62 and we're wanting to find out how many more than 29 is 62, it's really thinking addition, doing some comparison. I start with the 29. So I have 29. I'm doing this as a missing addend. How many more than 29 is 62? And if any teachers are watching, do you notice how I've organized these ones so that I recognize immediately it's a 9? I'm using like a 10 frame representation for this. Parents, a 10 frame typically is a 2 columns of 5 squares put together. A 5 by 2, we turn it horizontally, vertically. The orientation of that frame does not change its value. It's always 10. So you'll see that being used. So that's a quick way to recognize values less than 10. And then we use it for place value and for teen numbers. But in this case, I'm doing it because I don't want to watch the children have to keep recounting if they're not remembering how many they put there. So we've got 29, and we're going to count up. How many more than 29, 62? Well, 1 is 30, 40, 50, 60, 61, and 62. 62 is 33 more than 29. I could do the same idea with our 232 minus 199 problem. These problems that have traditionally required regrouping, as that's the one procedure we lose, we learn a single procedure. Now we have other approaches which get us at missing addend. That's going to be very helpful later. Get us at counting up. Okay. Now, I can do the same idea with one other model. And that model, I'm going to use what we call an open number line. Now, this really isn't new. Many of us have used number lines for years. Quite often, the number lines that we use start at 0, might have all the hash marks in between. An open number line is just a segment of it. It lets us focus in on one segment and then look at the endpoints of that segment. Okay, and I'm again going to find out how far apart these numbers are. And I can do it with jumps. So if I do this, right, I could do a jump of 1 that gets me to 30. And I apologize that this will not be to scale, I'm sure. I do a jump of 30 to get me to 60. Sorry, this was 62. And then I can do a jump of 2 to get me to 62. Okay, 33 total. Now, I could have done jumps of 10. Great. Some children will do jumps of 1 all the way up to 62. It's fine mathematically, just not efficient. Now, some of your children, I've seen, figure out the answer first, and then they do one jump of 33. That mathematically is correct too. The problem is that's not going to help us necessarily when we're doing more complex problems or those mixed number and decimal problems they'll get later on. That drawing the picture to match the answer is different than drawing a picture to match the process. And we want to be flexible. Now, children who do this usually are quite comfortable with those procedures, that algorithm that they've learned. And one way to challenge them, and that I challenge them, is instead of going to larger numbers, I say, great, I want you to do this in exactly 6 jumps, 1 must be 18. Or 1 must be 18, 3 must be the same. You see, that is a quite challenging problem to do, and I'm not needing larger numbers to challenge your children who are good with those procedures, and it will help build the flexibility side of procedural fluency. So we're trying to build strategies so that when they get up into 4th and 5th grade and the endpoints look something like this, when they're subtracting 5 1/4, right? Subtracting 2 3/4 from 5 1/4, this same strategy works. Jump a quarter, jump 2, jump a quarter. We're wanting to make sure they have that flexibility because that regrouping procedure we learned becomes very complex here, where this is a much simpler approach. I hope that's helped to give you some ideas of the subtraction strategies we're using in grade 2, why you might be seeing some of the materials and pictures that you're seeing. If this has been helpful, I hope you'll like the video and please subscribe so you know when other videos are available. If you have children in other grades, I hope that you will take a moment to watch those videos, those grade level specific videos. And I hope to see you in another video. Thanks for watching.